Friends, welcome to Thinking Gap. അപ്പോൾ തിങ്കിങ് ഗ്യാപ്പിൻ്റെ മറ്റൊരു ക്ലാസ്സിലേക്ക് നിങ്ങളേവരെയും ഞാൻ സ്വാഗതം ചെയ്യുന്നു. ഇന്നത്തെ ക്ലാസ്സിൽ നമ്മൾ ഡിസ്കസ് ചെയ്യാൻ പോകുന്നത് പോളിടെക്നിക് ലെക്ചറിനും അതുപോലെ തന്നെ കേരള വാട്ടർ അതോറിറ്റിക്കും ഒരുപോലെ പ്രയോജനമാകുന്ന ഒരു ക്ലാസ്സാണ്. മെക്കാനിക്കൽ എഞ്ചിനീയറിംഗിൻ്റെ നമ്മുടെ തെർമോഡൈനാമിക്സിൻ്റെ ക്ലാസ്സാണ് ഇന്നത്തെ ക്ലാസ്സിൽ നമ്മൾ ഡിസ്കസ് ചെയ്യാൻ പോകുന്നത്. നമുക്കധികം സമയം കളയണ്ട, നേരെ ക്ലാസ്സിലേക്ക് പോകാം. സോ ഇന്നത്തെ ക്ലാസ്സിൽ നമ്മൾ ഡിസ്കസ് ചെയ്യാൻ പോകുന്നത് മെക്കാനിക്കൽ എഞ്ചിനീയറിംഗിലെ തെർമോഡൈനാമിക്സിനെ പറ്റിയിട്ടാണ്. സോ വാട്ട് യു മീൻ ബൈ തെർമോഡൈനാമിക്സ്? Thermodynamics means it is a branch of physics that deals with heat and temperature and their relation to energy, work, radiation and properties of matter. So it deals with the heat and temperature and their relationship to energy, work, radiation and the properties of matter. Next we are going to discussing about the terminologies of thermodynamics. Terminologies. So terminologies, first one is thermodynamic system. First one is thermodynamic system. So thermodynamic system is a precisely defined region of the universe under study. It is the system is precisely defined region of the universe under study. Everything in the universe except the system is called the surroundings. Everything in the universe except the system is called the surroundings. A system is separated from the remainder of the universe by a boundary. A system is separated from the remainder of the universe by a boundary. Exchanges of work, heat or matter between the system and the surroundings takes place across this boundary. So the exchange of work, heat or matter between the system and the surroundings takes place across this boundary. And the second one is thermodynamic state. Second one is thermodynamic state. Thermodynamic state. So a thermodynamic state of a system is its condition at a specific time that is fully identified by value of a suitable set of parameters known as state variables, state parameters or thermodynamic variables. So a thermodynamic state of a system is its condition at a specific time that is fully identified by value of suitable set of parameters known as state variables, state parameters or thermodynamic variables. So we are going to discussing the terminologies in third one is internal energy. Third one, internal energy. So internal energy of a system is the energy contained within the system. Energy contained within the system is called internal energy. And the fourth one is adiabatic process. Adiabatic process. So adiabatic process occurs without loss or gain of the energy by heat. So adiabatic means occurs without loss or gain of energy by heat. Next one is isentropic process. Fifth one is enthalpic process. So it occurs at a constant enthalpy. It occurs at a constant enthalpy is called isentropic process. Next one is isentropic process. Isentropic process. Isentropic process. So isentropic process is a reversible adiabatic process occurs at a constant entropy. So it is occurs at a constant entropy is called isentropic process. And next one is isobaric process. Isobaric process. Isobaric process. So isobaric process occurs at a constant pressure. Isobaric process occurs at a constant pressure. And the next one is isochoric process. Isochoric process. Isochoric process occurs at a constant volume. Constant വോളിയത്തിൽ ഒക്കേഴ്സ് ചെയ്യുന്നതിനാണ് ഐസോകോറിക് പ്രോസസ് എന്ന് വിളിക്കുന്നത്. ഇറ്റ് ഈസ് ഓൾസോ കോൾഡ് ഐസോമെട്രിക് or isovolumetric process. So isometric or isovolumetric process. Next is isothermal process. Next one is isothermal process. So isothermal process occurs at a constant temperature. Constant temperature occur ചെയ്യുന്നതിനെയാണ് isothermal process എന്ന് വിളിക്കുന്നത്. Next is steady state process. 10th one is steady state process. So steady state process means it occurs without a change in the internal energy. So steady state process occurs without a change in the internal energy. So next is thermodynamics is principally based on a set of 4 laws which are universally valid. They are first one 0th law, second one first law, second law and third law. So first we are going to discussing about 0 law. Zero law. The zero law of thermodynamics states that if two thermodynamic systems are each in thermal equilibrium with a third one, then they are in thermal equilibrium with each other. Accordingly, thermal equilibrium between system is a transitive relation. So thermal equilibrium between system is a transitive relation. This statement implies that thermal equilibrium is an equivalence relation on the set of thermodynamic system under consideration. So the statement implies that thermal equilibrium is an equivalence relation on the set of thermodynamic system under consideration. So the physical meaning is expressed as all heat is the same kind. So the physical meaning is expressed as all heat is the same kind. Another statement of the law is all dihedral walls are equivalent. So next the statement of this law is all diathermal walls are equivalent. All diathermal walls are equivalent. These are all about the zero law. And the second one is first law of thermodynamics. So second one is first law of thermodynamics. So the first law of thermodynamics says that in a process without transfer of matter, the change in internal energy, that is delta U of a thermodynamic system, is equal to the energy gained as heat Q less the temperature thermodynamic work W done by the system on its surroundings. So in a process without transfer of matter, the change in internal energy delta U of a thermodynamic system is equal to the energy gained as heat Q less the thermodynamic work W done by the system on its surroundings. So delta U is equal to Q minus W. Delta U is equal to Q minus W, where delta U is the change in internal energy. Delta U is the change in internal energy. Q is the energy gained as heat. Q is the energy gained as heat, and W is the thermodynamic work. W is the thermodynamic work. The first law of thermodynamics is the version of the law of conservation of energy. Law of conservation of energy adopted for thermodynamic process. So the law of conservation of energy says that energy can neither be created nor be destroyed. So one form can be transformed into another form. So energy can neither be created nor be destroyed, but one form of energy can be transferred from one form to another. So these are all about the first law. Delta U is equal to Q minus W. Delta U is equal to Q minus W. So the third one is second law. Third one is second law of thermodynamics. So the second law of thermodynamics states that the total energy of an isolated system can never decrease over time. Never decrease over time, and is constant if and only if all processes are reversible. If and only if all the processes are reversible. In other words, heat cannot spontaneously flow from a colder location to a hotter location. അപ്പോൾ നമ്മൾ വേറൊരു രീതിയിൽ പറയുകയാണെങ്കിൽ heat cannot spontaneously flow from a colder location to hotter location. Isolated process spontaneously evolve towards thermodynamic equilibrium, the state with the maximum entropy. So it will thermodynamics equilibrium that evolve towards thermodynamic equilibrium, the state with the maximum entropy. The second law is concerned with the direction of natural processes. The second law is concerned with the direction of natural processes. A peripheral motion machine is a hypothetical machine that can do work indefinitely without an energy source. So a peripheral motion machine is a hypothetical machine that can do work indefinitely without an energy source. The second law declared the impossibility of such machine. So the second law declared the impossibility of such machine. So that is all about the second law. And fourth one is third law. So the third law of thermodynamics states, as the temperature of a system approach absolute zero, all processes cause and the entropy of the system approaches a minimum value. So the approaches the minimum value. The entropy of all systems and all states of a system is smallest at absolute zero. Smallest at absolute zero. This law provides a absolute reference point for the determination of entropy. So the absolute reference point for the determination of entropy. It is impossible to reach the absolute zero of temperature by any finite number of processes. So it is impossible to reach the absolute zero of temperature by an infinite number of processes. These are the laws of thermodynamics. Zeroth law, first law, second law and third law. അപ്പോൾ നമ്മുടെ തെർമോഡൈനാമിക്സിൻ്റെ ഇന്നത്തെ ക്ലാസ് ഇവിടെ അവസാനിച്ചിരിക്കുകയാണ്. നിങ്ങൾ ക്ലാസ് നന്നായിട്ട് കാണുക, ആദ്യം മുതൽ അവസാനം വരെ കാണുക, നോട്ടുകളെല്ലാം എഴുതിയെടുക്കുക. ഞങ്ങളുടെ ചാനൽ ആരെങ്കിലും ആദ്യമായിട്ട് കാണുന്നതെങ്കിൽ ലൈക്ക് ചെയ്യുക, ഷെയർ ചെയ്യുക ആൻഡ് സബ്സ്ക്രൈബ് ചെയ്യുക.